Good afternoon, everybody. We're just going to take a couple of minutes to allow everyone to join in. Excellent. It's so great to see such a good turnout this afternoon. Welcome, everyone, to the Ontario Association of Certified Engineering Technicians and Technologists first annual virtual capstone project competition. We're so glad that you could join us this afternoon. I think you're going to be blown away by the amazing projects that you're going to see presented here today. As we kick things off, I ask that you join me in acknowledging that this land has been a site of human activity for thousands of years. We honor and respect the diverse Indigenous peoples connected to the territories from which each of us is joining the meeting today. We recognize the enduring presence of Indigenous peoples on this land and express our gratitude for the opportunity to live, work, and gather here. We're committed to understanding and acknowledging the histories, cultures, and contributions of Indigenous peoples, and we strive to build positive and respectful relationships. As we engage in our discussions and activities today, let us carry forward this acknowledgement and commit to working towards recognition, reconciliation, understanding, and collaboration with the Indigenous communities in Ontario, and to continuing the stewardship of the land we all call home. I'd like to start off this afternoon by providing a bit of background to today's event. One of OACETT's key mandates is to raise awareness of the contribution and competence of our certified engineering technicians and technologists. For many years, one of the strategies for doing that was through participation in National Engineering Month, or NEM. However, over time, we realized that NEM still wasn't helping us to differentiate ourselves from engineers, and we were kind of being lost in the shuffle. So, when the 9 provincial organizations representing engineering and applied science technicians and technologists across the country reunited under Technology Professionals Canada, or TPC, in 2019, we started to talk about how we might be able to come together to enhance the collective profile of our profession, which was one of the agreed national strategic directions. In 2023, the members of TPC agreed to establish a National Engineering and Applied Science Technology, or NEAT Week, scheduled to launch in the last week of November in 2024. NEAT Week is intended to consist of a number of different activities involving our members, our post-secondary partners, other stakeholder organizations, and of course, the public at large. As part of our planning, we agreed that there was going to be one key anchored national event, and that was going to be a National Capstone Project Competition. Most of the 3-year advanced diploma programs in the schools of technology across the country have culminating capstone projects, an opportunity for students, either individually or in teams, to pull together all their learning and experience over the course of their 3 years of study into one overarching project. Sometimes those projects have corporate sponsors and are designed to solve real-world problems. Others are simply the brainchild of extremely creative and talented students. Either way, I've had the privilege of seeing a number of those projects, and it's definitely an ideal way to showcase what engineering technology is all about. However, in order to have a national competition in November, that means there needs to be a way to select the winning provincial projects that are going to compete at the national level. And that is what today is about in Ontario. Together, we are going to select the winning project that will represent our province and our association at the national competition, which will take place on Tuesday, November 26th at 1 p.m. Eastern Time. That is also going to be a virtual event, and the link to the register has just been shared for you in the chat. Before we get started with the competition, there are a couple of other people that we'd like you to hear from. In the interest of full disclosure, there are a number of video presentations to be presented today, and sometimes video technology in webinars can be finicky, but we're hoping that they cooperate with us today, because we are very pleased to kick off the webinar with greetings from Premier Doug Ford.
Hi everyone, I want to give a big shout out today to everyone taking part in the National Engineering and Applied Science Technology Week. Engineering and technology professionals play such an important role in our economy, from keeping our electrical grid and manufacturing facilities running, improving our highway and transit infrastructure, to helping us build homes. Your contributions are truly appreciated. I especially want to give a big shout out to the Ontario Association of Certified Engineering Technicians and Technologists for organizing NEAT Week and for encouraging more young people to get involved in the field. Wishing you all the very best and God bless.
A big thank you to Premier Ford. When we talk about raising the profile of our profession, one of our key target audiences obviously is government. They need to understand the value of the collective expertise and contribution of our members. It doesn't get much better than making our way to the very top with the Premier. Ontario's Minister of Colleges and Universities, Nolan Quinn, also offers his greetings and support for today's event.
Hello everyone, and thank you to Ontario's engineering technicians and technologists for inviting me to speak to all of you today. It's really neat to be part of this competition. I always appreciate having the opportunity to be a part of a great event like this one that encourage innovation and highlight the talent of Ontario's remarkable post-secondary students. To the participants, congratulations. Your talent is truly incredible, and your hard work deserves to be celebrated. Your success in the months and years to come is going to make a real difference in the growth of our province, and you should be incredibly proud of yourselves. As a college graduate and a previous business owner, I know firsthand that Ontario's colleges are well equipped to support students' unique talents and prepare them for the workforce. There are so many extraordinary, well-respected STEM and skilled trade programs offered at institutions all across our province. And I want to say thank you to the wonderful staff and faculty who are helping build a highly skilled workforce for today and tomorrow. Ensuring that we have workers who can adapt and fill jobs that industries need is important. The highly skilled engineering and applied science technology experts you're going to become will help us to build more homes and highways and strengthen our automotive and advanced manufacturing sectors. All the things our modern economy needs to stay competitive. The National Engineering and Applied Science Technology Week is the perfect time to celebrate students and workers in these fields. It is important that we continue to showcase the exceptional talent we have in our province and inspire young Ontarians to pursue education and careers in STEM. There are already nearly 70,000 students in STEM programs in Ontario, and we can always use more. I know that the students who go on to represent our province at the national level will make us proud and show that Ontario is a strong leader in engineering and applied science technology. Good luck to all of you participating. I can't wait to see what you accomplish.
And a big thank you to Minister Quinn as well. I particularly appreciated his playing off the NEAT week in his video and the great support for college programming. So now that we have the formalities looked after, let's talk about how today's competition will work. Every college in Ontario was invited to identify a project for submission to the competition. Each submission needed to include a brief description of the project, the full supporting technical report, the instructor's grading of the project, and most importantly, a video presentation of the project by the students. All the submissions were received by the deadline of September 24th, were reviewed by OACETT's Awards Subcommittee. Using a scoring matrix that evaluated project originality, technical ability and proficiency, methodology, practicality, creativity and innovation, results and conclusions, and community leadership and importance to society. So there were a lot of aspects to review. The awards subcommittee selected 3 finalists from among the submissions. Those 3 finalists are the presentations that we are going to see today. We're using the video presentations that the students submitted because most of these students have now graduated, and on the advice of our college partners, the logistics of trying to bring them all back together in person to present just wasn't practical. But the videos will certainly give you a great introduction to the work that each team has undertaken. And then it's going to be up to all of you. In a format reminiscent of Canada's Got Talent, we're going to watch the 3 video presentations together, and then you will each be invited to vote on the project that you think should represent Ontario in the national competition on November the 26th. So let's introduce our first project. Just a note for everyone, these projects are being presented in alphabetical order according to the name of their college. There's no other implication to the order of the presentations. So the first video that we're going to show today is from the research team at Mohawk College's Construction Materials Laboratory, headed by Tyler Thiem. This project was conducted in partnership with Lafarge, who assisted Mohawk College in acquiring a certification from the Canadian Council of Independent Laboratories. Tyler's capstone project is named Recycled Material Compared to Virgin Quarried Material. As the name suggests, the purpose of the project was to compare recycled material to virgin quarried material to determine if recycled material could be used in construction projects in order to reduce the impact on the environment and to address supply shortages. So let's find out more. And as I did mention at the outset, technology is lots of fun as we try to manage the multiple videos. I'm just seeing a quick note in the chat about where can I vote. The voting actually won't happen until the end of the 3 presentations, and we'll launch a poll at that time. And that's how you will be able to register your vote. There is a question I see in the chat as well about whether the session is being recorded. And yes, it is. So it is going to be available afterwards on OACETT's website in the Neat Week section. So I think we might have our first video primed and ready to show now for Mohawk College. So sorry for the delay. There we go.
Mohawk College partnered with Lafarge to conduct an unbiased assessment on recycled material compared to quarried virgin material. There's a discrepancy where at a provincial level, recycled material is accepted, but there's some hesitation to implement the use of this in municipalities. So this was conducted in hopes that municipalities would see that recycled material does possess the same properties as virgin quarried material.
A large part of this project is that it was CCIL certified, so that's the Canadian Council of Independent Laboratories. For this certification process, there were 2 main aspects. Number 1 was getting the lab certified, So that involved doing a large inventory of all the equipment we had in the project and making sure it was all up to the specifications of CCIL. And the next step was ensuring all the students and the students working on the project were all certified. The student CCIL certification process involved a lot of training. A lot of these tests that we did, we covered in class through the Civil Engineering Technology program here at Mohawk College. There are some other tests that were not covered, so we went over that training with the professor, Irina Mogg. We also went through the Lafarge labs and quarries, and we went over training on specific projects with them as we were going to do our third-party research for them.
Thanks to this certification, this lab is able to test several types of materials and to present these results to the industry. It allows the students to have in-hand experience working with these type of materials, because these materials are the ones that are out there in the industry. Having a lab certified and maybe having yourself certified as a CCIL technician will give you a head start.
In total, each sample got about 13 tests. It ranged from tests such as doing a specific gravity to doing proctors on them. There were 3 issues. The first one was finding foreign materials in the object that we weren't expecting. Of course, there was going to be stuff in the recycled material that we knew was going to show up, such as like brick or rebar, plastic, glass. But there were foreign objects such as metal shavings that were showing up, and it didn't necessarily impact the testing quality, but it's just a bit difficult to work with, and it wouldn't be ideal to sell as a product to have metal shavings in your aggregate. The second issue that we found was with the absorption capacity for some of the recycled materials, was that they were having a lower density, maximum density, and a higher absorption capacity. The issue is that for most of the quarried or virgin material, they would absorb at the anticipated amount that we put in the proctor. It's not going to splash everywhere. So whereas recycled, it's compacting, but now it's not absorbing water and it's splashing all over the place. The last issue that we faced was with the samplings coming in. One site was sending us samples. So every 2 weeks, they're supposed to send us bag samples from that production line for that cycle. And it happens every 2 weeks, but instead they were sampling all in one day from that same source. We disqualified those.
I wanted to be involved in these research projects as I enjoyed the courses we take here at Mohawk College involved in materials testing. I also thought it would be a great opportunity to get involved in research, as I always think there's new opportunities in certain fields, especially in construction, it's such a large field. And lastly, a research project such as this works with a lot of sustainable materials, and I think that's going to be great going forward.
For me personally, working in a municipality setting, I've seen the reluctance to implement recycled materials. And as someone who cares about the environment, I think it's a little discouraging. So having the opportunity to, examine recycled materials versus virgin quarried materials and see the similarities between the properties that they possess and that it can be implemented, I think it was neat to learn about what more could be done to move forward.
That is some excellent work from Mohawk College, and we thank them very much for that submission. Next up, I would like to present a capstone project submitted by Andres Mauricio Pinto-Bote and Matt Molds from Seneca Polytechnic. Their project, named Automated Parts Dispenser, consisted of creation of an automated parts dispenser that reads barcodes on order bins and then fulfills orders by dispensing the appropriate number of parts, from dispensing screws, nuts, and washers to preloaded magazines. The purpose was to automate repetitive tasks in manufacturing in order to shift labor to more complex tasks. So let's play that video now to find out more.
Hi, I'm Matt, and today my colleague Andres and I will be discussing our capstone project that we've been working on for the past 12 weeks or so here at Seneca College. So we're both in the electromechanical program, and we're looking to graduate within the next couple weeks or so. This was the final project that we were working on for that course. So to start us off, I wanted to talk about some of our initial goals when we started looking at this final capstone. And for that, we're both, again, as I mentioned, in the electromechanical program, so we wanted something with a bit of an industrial bend. And we wanted to be able to practically apply some of the knowledge that we've learned in the past few semesters regarding logical programming, control circuits, mechanical design, CAD software. We wanted to put that all together and find a nice project that we'd be able to demonstrate those skills with. So some of our initial inspiration for this came from vending machines. Vending machines are pretty simple devices. We probably don't think about them a lot, but we come across them every day. But they do incorporate a lot of the different ideals that I just discussed. There's some mechanical movement there. There's some logical programming. And so we were thinking about that initially, but again, we wanted something with an industrial bend. So we thought that rather than dispense an assortment of snacks and beverages, we could dispense small parts like screws, nuts, and washers. So why did we choose this idea? Well, automation of repetitive tasks is a constant theme in manufacturing. So there's a practical relevance to this. Whether it's for internal customers or external customers, there's always a need to pick large amounts of inventory for small parts to prepare it for, let's say, an internal assembly or for an external order. So picking precise numbers of small parts is a perfect opportunity for machinery to automate and take the place of manual labor. There's also a lot of transferable logic with a machine like this. So even if this specific device isn't used in the marketplace in the future, it still provides a very good learning opportunity for us to explore a lot of the different ideas of the things that we wanted to learn more about. So with that in mind, we developed a few supplementary goals for our project here. Number one, we wanted a small footprint. This was mostly just for practical reasons. It helps to both keep our budget down, and as well, we knew we'd have to be bringing this to school and back to our homes quite a bit throughout the semester. So a small footprint was beneficial for that, and also space is a premium. So whenever we can make something smaller, and if we're capable of doing that while maintaining functionality, that's a big benefit. We also wanted a modular design. So we wanted to make it fairly easy to adjust this design to work with different part geometries. We wanted an appropriate budget, again, for some of the reasons discussed earlier. We're both students, we're not millionaires, so we wanted to keep this reasonable. We wanted an intuitive user interface. So we wanted someone to be able to come up to this machine and very easily adjust the amount of parts they wanted to dispense for each order. With that in mind, too, we wanted to incorporate a barcode reader. So this would be mainly to enhance automation. So you could associate a barcode with an order, stick a bin on the machine, have it read that barcode, and automatically know how much parts it needs to dispense. And with that in mind, for a prototype, we wanted to dispense screws, nuts, and washers from preloaded magazines. So once we had laid out those goals, we created a project description. So this is just a quick overview of basically exactly what our project here does. So our proposed project is an automated parts dispenser. It will read barcodes on order bins and then fulfill orders by dispensing the appropriate number of parts. The prototype will dispense screws, nuts, and washers, as mentioned, from preloaded magazines. With those goals in mind, we moved on to the design phase of our project. One of the first things we did was determine what inputs and outputs we'd need and how those would all interface with our project as a whole. So as our main control, we chose a PLC. In our case, we used a Click Plus, which is just a budget-friendly unit. For our inputs, we needed the barcode reader, as previously mentioned. We used optical through-beam sensors to measure position along the conveyor belt. We used optical diffuse sensors to measure our inventory when it was low. And we used some limit switches to measure whether or not our solenoids were retracted. As outputs, we used 4 DC solenoids, and these were to manage the actual dispensing of our parts. We used some small LEDs. These were just as indicators for low inventory and whether or not the process was active. As well, this PLC we wanted to interface with an IoT interface. So in our case, we were using Node-RED, and we were using MQTT protocol to connect to the PLC. And from that, we could control and have that user functionality. With those main parts designed, we incorporated them all into the overall build. With the mechanical portion more or less taken care of, we had some electrical issues to sort out. So for our project, we developed two PCBs. This first one is pretty simple. This is basically just our power distribution module. So we take the 4 lines from a power supply for 24 volt, 12 volt, 0 volt, and 5 volt, and we just distribute that to big terminal blocks. This next PCB design is slightly more interesting. So this was for our indicator panel. We wanted lights to indicate when there was low inventory of any of the parts, as well as an active light that would flash whenever the process was active. And this is what that indicator panel looks like on the final build type here. And this is basically the main build. At the bottom, what we have going on is the conveyor belt, which is driven by the 12 volt DC motor here. We have our through beam optical sensors at the beginning, middle, and end to detect the bins. The barcode sensor mounted on the front to read. And then up top, we have where the actual action is happening with the dispensers for the washers, screws, and nuts. And they'll all fall through the funnel and into the bins. And in the back is where the PLC is for the main control, all our wiring for power, and the power supply is underneath. That's basically what's going on there.
For the automated parts dispenser, our machine here, we have the controls all on the IoT dashboard here on the PC. The PC is communicating with the PLC through MQTT protocol through this Ethernet cable. And yeah, well, basically here on the IoT dashboard, we control the values that are going to be dispensed in each bin according to the barcode that that is taught. In our case, we taught some of the barcodes previously to save some time. So these are the barcodes shown over here on the right. Those are the ones that we pre-taught. We're gonna teach one more bin later on to show how it's done. The machine has 2 modes, auto mode and manual mode. Each of them has their buttons. And then for the main screen of the IoT dashboard, we have the start and stop buttons, the inventory lights over here, the total count for manual, total count for each of the bins, and then total counts for each of the parts dispensed. So now, Matt, let's proceed to teach the bin number 4, which is going to be which barcode?
So I'm going to teach this barcode here, which is 5369743685544.
Perfect. So let's press teaching bin. Now Matt is going to scan.
I'm just going to scan the barcode here. And then it associates that barcode with bin number 4.
Exactly, so we can see.
Teach whatever values we want.
We can see the barcode over here. And then we're going to teach the values of 1 screw, 2 nuts, 3 washers over here. We're going to confirm bin 4 to send the values to the PLC. Then let's run the first demo on manual mode. So let's do 111. Confirm, value sent.
So the only difference in manual mode versus auto is in manual mode it's not scanning for a barcode or anything. It's just looking, and as soon as it detects a bin, it will dispense whatever numbers were taught in the manual mode. So we'll run that now. Are we going to start?
Oh, you're right. Let's start.
So we'll click start, and we'll see our little process active light is blinking. And we'll send this here. And we can see that we got 1 of each. Perfect. Next, we can run the ones that we pre-taught.
So first, we have to stop the machine to change the mode, as is said on the instructions. And then we can start the machine back.
So now it's in auto mode, so we'll be scanning for a barcode. And so that was the one for 2 screws, and we can see that we got 2 screws. Next, we'll do the one for 2 nuts. And we can see that we got our 2 nuts.
And again, thank you to our capstone contestants from Seneca Polytechnic. Great to have that walk through. They were time limited on their video, so that would have resulted in the endpoint. We have just one more submission to show you before we conduct the vote. And the final project comes from Vikram Pandey and Hugh Roy Staples from Sheridan College. Their capstone project, titled Hydrothermal Carbonization, or HTC, of plastic waste, investigated the hydrothermal carbonization, which is also known as HTC, process for converting different types of plastic waste into valuable resources, helping to address the growing environmental challenges caused by plastic waste. Plastic waste is indeed a problem. Almost everything we use comes from plastic, from our phones to our computers, even to our clothes. Trying to imagine a world without plastic is really hard because it's such a commoditized product. So without further ado, let's play Sheridan's video.
Hello everyone, thank you for joining us. My name is Roy and today I'll be joined by Vikram, and today we're happy to talk to you about our technical report on the hydrothermal carbonization of plastics, also known as HTC. Now, plastic waste poses a significant environmental threat, and this project aims to explore hydrothermal carbonization as a potential method of mitigating plastic pollution by considering alternative uses. Okay, so for today's presentation, we're going to take a look at a brief introduction to our topic, how we actually set up our experiment, how we analyzed our data, and some of the applications of our product, which is hydrochar, some of the recommendations for future research, and then a brief conclusion along with key references that we used for this presentation. Now, when we think of the HTC process, we're actually thinking of plastics being placed in a batch reactor with water for an extended period of time. Now, this normally occurs at high temperatures and high pressures, at which chemical reactions occur to the plastics present to break them down into a carbon-rich compound known as hydrochar that has a similar composition to charcoal, which we're familiar with. Now, our aim in this research project is to determine the optimal temperature in a range of 250 to 280 degrees Celsius for the HTC process to occur, and also to observe how changes in the temperature affect different parameters of the hydrochar product we're producing. Now, for this experiment, we decided to focus on plastics that are commonly found around us in our environment. This included PVC, PP, PC, LDPE, and PET. These samples are then processed into smaller pieces, placed into a sample holder, and then placed into a batch reactor with water for a total hold time of around 2 hours at high temperature and high pressure in order to create our hydrochar product. Now, after obtaining our hydrochar product, the success of our HTC process was evaluated on the parameters of carbonization, porosity, and heat flow, which was evaluated using instrumental techniques such as FTIR, microscopy, and the differential scanning calorimetry, results of which we'll discuss in more detail in the upcoming minutes. Now, before we take a look at our other results, something that's also very important is our yield analysis. Yield gives us an idea of the amount of hydrochar that's being produced for each unit of plastic that we're actually putting into the reactor. And we could also take a look at how temperature affects our yield, as can be seen in this graph here. We can actually see that for PVC, the yield is not as affected with an increase in temperature. For polypropylene, PP, we see that an increase in temperature results in a decrease in yield. For PC, we see that the yield is very low to begin with. And for LDPE, an increase in temperature actually results in an exponential increase in yield. As well as for PET, we see that an increase in temperature results in about a 50% increase in the yield we receive. Now, the usage of FTIR was essential to determine how temperature affected the breakdown of our plastic samples. And this is given as a function of absorbance that was determined from the FTIR spectra that was completed for each plastic sample. Now, a decrease in absorbance would actually indicate a greater decomposition of those samples. And this trend was actually observed for a majority of the plastic samples, as we do see a decrease in absorbance as we increase in temperature. However, we do see a bit of variability with the LDP results. Now, at this point in time, we've taken a look at a brief introduction to our topic, how we set up our experiment, along with some key pieces of data analysis. At this point in time, I'll hand over to my partner Vikram, who will continue with our data analysis, some of our applications, recommendations, our final conclusion, along with some of the key references that we used for this project. Over to you, Victor.
Thank you so much, Uroy, for explaining some of the key points of this project. Now I'll take further from here and I'll explain the data analysis at the DSC, which is digital scanning calorimetry, and we use it to depict the thermal behavior of the sample. As you can see in the slide, there are two graphs which actually shows the degradation behavior, the thermal behavior of the PVC sample at 250 and 280 degrees Celsius. As we can see from the graph, the sample at 280 has a lower residual weight, which is around 10% compared to the one at the 250, which has somewhere around 40%, so indicating the more complete degradation. So exothermic peaks during the deterioration and the moisture loss at the lower temperature were seen in both the sample, and PVC didn't experience any mass increase during oxidation like coal does, which indicates a similar combustion process and decrease the chance of spontaneous ignition. So unlike coal, PVC didn't show any oxy-complex formation, which leads to the faster combustion of our material comparing to the theoretical data of the coal combustion, and which has a different thermal characteristic because of this only. And both materials showed similar initial moisture and the combustion behavior. So now I would like to talk about the data analysis on the digital microscopy. As you can see, there is a chart in the slide which actually tells about the porosity, the pore size of the PVC sample, which we did the carbonization at 250 and 280. At 250, as you can see, the average pore size is just over 20, and at 280, it's over 30. So we did this advanced imaging, using the software which integrate the data from the digital microscope to determine the average pore size. And by comparing all of these, we found a very quantifiable data for the PVC, and we observed these at 1000 magnification times 1000 magnification, and that's how we measured the pore size. The size which we talked about for the PVC sample in the last slide at 250 and 280, as you can see, we measured the size by the digital imaging, as I mentioned already as well. But why there is a pores? The reason for the pores is mainly from the polymerization process and the structure. During suspension polymerization, water act as a medium and get drawn into the forming the polymer droplets. So when the water drop is removed, it leaves behind the interconnected pores within the PVC sample. So with the increase in the temperature, the pore size increases, as you can see, and it's very evident from the picture as well. And why is the pore size very important? Since the pore size is very crucial because they directly affect the material surface area and the possible uses. Since the larger pores can enhance the material ability to absorb substances, making it more effective in applications such as filtration or as a support material in chemical reaction. So pore diameter can increase the efficiency of the STC process. So we can conclude that by allowing it for the more contact between the material and the substance it react with. So that's how we can increase the porosity as well.
So there are some applications of the HTC, since it's a very innovative process that transforms the plastic waste into the hydrochar. It's act as an energy source which can be burned as a fuel alternative to the coal. It helps in the agriculture by enhancing the soil health. It helps in environmental cleanup by absorbing the harmful chemicals from the soil and the water, and some of other like waste management and the climate action. So overall, it's a very sustainable method of improving our waste management practice. So in order to improve this experiment for future and build upon on this project, we have several key recommendations. So first is increasing the drying time, so at least 3 to 5 hours. The second one is the running the sample trial at the higher temperature, because we saw that PET and PP showed better degradation, better decomposition at the higher temperature. So we recommend any experiment above 285 degrees Celsius would be better to know the impact of the carbonization. The third one is improving the sample separation. So we can use the stronger steel containers or running one sample at a time so that the better separation can be possible there. And the lastly is increasing the feed density by palletizing the sample, the outcome. So that's how we can increase the feed density, and which can improve the yield. So with this, I would like to conclude our presentation for the project hydrothermal carbonization process. And in the result, we saw that PVC had a stable yield both at 250 and 280 degrees Celsius, likely due to its very strong structure even after dehydrogenation and dechlorination. And PP, LDPE, and PET, we saw the increase in yield at the higher temperature. And from the FTIR analysis, we showed the breakdown of the functional groups. While PVC had a minimal changes, and PP and other plastic, they show significant degradation. Further, we did the DSC analysis to highlight the thermal properties and found that it has very similar properties as of the coal. And with the microscopic examination, we found the porosity as it increased with the increase in temperature, and it was visible in the PVC, but it was not very significant in others. So overall, STC effectively converted the plastic into the hydrochar. And these are some of the references which we use for our experiment and this presentation. Also with this, I would like to say thank you so much for being until the end of this presentation, and I hope you liked our presentation. Have a good day ahead.
And congratulations as well to the Sheridan team. I told you were going to be blown away, and that's exactly what we've been seeing in some of the comments that you've been posting as well. And now for the moment of truth. In just a minute, we are going to launch our voting poll and give you the ability to vote on which project should move forward to the national competition. In case you need some help in deciding, I'm just going to provide another reminder of the criteria that our awards subcommittee used and which you can see on the PowerPoint slide. It was project originality, technical ability and proficiency, methodology, practicality, creativity and innovation, results and conclusions, and community leadership and importance to society. So, ready? Then let's launch the poll. And voting is only possible during the webinar today. It's only possible with the poll online. So please go ahead and select your preferred project. We're just leaving a couple of minutes for the final tally to come in. Staff, I'm going to need you to provide me the results of the poll because it's not appearing from my screen. And there we have the results. I believe everybody can see the results posted on the screen. And quite incredibly, we have ended up with a tie. So we had 22% of the vote to the Mohawk project, 39% of the vote to the Seneca project, and 39% to the Sheridan project. So that is just fabulous. Staff did place a consideration in advance that what we would do is we would, if there was a tie, we would look at the scores that the awards subcommittee provided to each project, and that would allow us to make the decision between the three projects, and we will be able to provide that announcement to the individual the individual projects after we've been able to look at that final tally. Just to let everybody know what does happen with the winning projects. So once we can determine which one of the two projects is the winner based on the awards committee scores, the winning team is going to share a cash prize of $1,000, and there is going to be a banner and a trophy that will be on display at the college for bragging rights. The project is also going to be featured in the January and February edition of the OT magazine. The second place team will be sharing a cash prize of $700, and the third place team will share a cash prize of $300. I know it's cliche to say it, but I think everyone was a winner today, with the biggest winner being the future of our profession, as demonstrated by the caliber of these graduate level projects. I would like to thank everybody so much for your participation today and for helping us to select Ontario's entry for the National Capstone Competition. One more reminder that NEAT Week is taking place the week of November 25th, and the National Capstone Competition takes place on Tuesday, November the 26th at 1 p.m. Eastern Time. And again, the link to that project is apologies, I'm getting late breaking notes into my desk. The link to that is provided. The link to be able to register for that webinar is it was provided earlier in the chat, and I'll ask staff to add it again. There are a couple of other things that are taking place during NEAT Week. On Thursday, November the 28th at 1 p.m. Eastern Time, there's going to be a webinar on AI and the specific implications for engineering technology. This webinar is going to be free to all OACETT members and to the members of all the provincial associations, because this is being hosted by Technology Professionals Canada. And it's also available to all the students and faculty in engineering and applied science technology programs in the colleges and polytechnics across the country. And then we have one more NEAT Week treat, and this one is specific to OACETT and to Ontario. On Wednesday, November the 27th at noon Eastern Time, Kathy Lorette, CET and fellow OACETT, will deliver a webinar on the future of electrification in Ontario and the implications for engineering technology, informed in part by survey responses from the over 800 OACETT members working in electrical utilities across the province. Now, I am just going to scroll back because staff was able to provide me with the order of scoring for the projects by our awards subcommittee. So I am pleased to advise that the winning project is the project from Sheridan College, which was the final project that we saw on hydrothermal carbonization. And the number 2 placed project is the project from Seneca College, which was the automated parts dispenser. So I'm pleased to be able to offer the direct congratulations while we are on the webinar, and so that you know where the bragging rights are coming back. So huge congratulations to the team from Sheridan College, Vikram Pandey, and Hugh Roy Staples. And so with that, I do just want to advise, we will obviously be sending you some more reminders between now and the end of November about the activities that are taking place during NEAT Week. And there should be many more that are coming forward, because we are hoping to undertake lots of different projects with both our college partners and with our chapters across the province. If any of you have a great idea for a NEAT Week project or a NEAT Week activity, my email address is on the screen, and you're welcome to let me know, or you can make a note even right now in the chat, because we'll be able to take advantage of that afterwards. We certainly hope that at minimum you'll be able to take advantage of all 3 of the main events that we have, which is the National Technology Capstone Project, the electrification webinar on the Wednesday, and then the Thursday webinar on AI. A big thank you very much for joining us this afternoon. Thank you again for your patience with the technology, which didn't work as ideally as we would like to, but I know you still were all able to take advantage of the fabulous work that the students put into these projects. This is our first year with the competition. We can only imagine that we will have even more submissions and more exciting information to share with you next year. So continue to keep an eye out for this as an annual event through OACETT. Please enjoy the rest of your day.